There it is.
The world is warming. The Arctic in particular is warming 4 times faster than the global average. We're seeing glaciers retreating faster than ever. One of the things that we were interested in studying are the impact of the thermohaline circulation on Svalbard. Surface ocean circulation travels across the tropical zone. As it hits North America, forms what many people know as the Gulf Stream. And that Gulf Stream water is warm, and it travels up the East Coast and then transits eastward across the Atlantic Ocean. And as it does, it's cooling, it becomes denser, higher salinity, and therefore it sinks. So this conveyor belt, as you see in this video, travels to the north, up into near Iceland and actually up along the Norwegian coast. And this warm water can actually impact the melting of the glaciers. And it reaches all the way up to Svalbard. This warm water was not in the fjords prior to 2005. So we had normal sea ice cover in the fjords. In the summer, the fjords would open up, and we'd have this very cold circumstances of the water column in front of the tidewater glaciers. But since 2005, there's so much heat coming from the North Atlantic water into the fjords that often the fjord does not freeze in the wintertime. And it's causing much increased melt rates at the tidewater face. So what we do in our research is to join with dozens of other scientists in mapping the temperature of the water column in front of the glaciers so that we can track the intensity of that warm water and the influx of that water against the ice sheet. And so from 2005, 2009, 11, and 14, I took groups of undergraduate students up to Kongsfjord so they could themselves experience and develop a science problem, make observations, and then decide what to measure and evaluate. And so we were really lucky in 2021, funded by the National Geographic, to go back and continue our work.
My main role on the project was to operate the bathymetry equipment and software. So we were looking at how much sediment was coming off the glacier. So as the glacier is melting, all of the sediment that it carried over the land ends up in the ocean where the glacier retreated, and it can change the surface of the ocean floor quite dramatically.
The other thing that we did is that every year we were up there, the first 4 years, we always took a middle school teacher.
I was accepted to a program called Polar Trek, which accepts a number of science teachers and scientists in doing polar research. And I hit the jackpot and got teamed up with Julie Brigham-Greddy.
These middle school teachers helped us communicate out to their students, to their school system, to their parents, what was happening in the Arctic. They helped me try to understand how to communicate better about what's happening with climate change. How do you make it relevant?
It was a great experience just getting to work with 3 other scientists. It was cool because we all kind of took different roles, just naturally. We also just became good friends.
Svalbard continues to warm faster than any other part of the Arctic. And so we're seeing really the complete transition of a major ecosystem. The data we've collected will be shared with dozens of other scientists who also have similar data in other times of the year, so they can look at the whole ecological change that's happening, not only with what's happening with the ice, but what's happening with the local ecosystems that survive in these fjords, and using and making use of the landscape that's now newly emergent there. So we hope what we've done is to share with the general public who don't have the opportunity to go to places like this why what's happening in the Arctic is so important to us here in the lower latitudes. Because what happens in the Arctic doesn't stay in the Arctic. In fact, what's happening at the high latitudes will in fact impact the entire globe. And it's important for that message to get out so we can be more mindful and urgent with our attempts to control and decrease the rates of climate change.